Would you like to learn how to graph sine and cosine functions by just looking at the numbers around them? Well, you're very fortunate because you've arrived just on sine. Sorry, I couldn't help myself. But anyway, want to learn some math? Let's go. In order to understand how to graph a sine or a cosine function, we want to understand what each of the numbers in the equation actually means. So let's break it down. So this A is pretty important because it's the amplitude. It's always the amplitude. And we're going to take the absolute value of this number to get how far we're going to go up or down from our middle line when we graph everything, or our sinusoidal axis. This D value is the sinusoidal axis. That's going to tell us where the middle of our function is. Some people call this the midline. Again, because it's right in the middle of our function. This C, and we're going to do the opposite of what it says. So if it says plus, we'll go to the left, and if it says minus, we'll go to the right. But what it tells us, it's a horizontal change. We call that a phase shift. So that's a horizontal translation, left or right, by a certain amount. The B value, like with other functions, is going to cause a horizontal change. This is going to cause a horizontal stretch or compression depending on what the number is. So if B is very small, it's going to cause a compression, a horizontal compression. Actually, let's reverse that. If B is very large, it's going to cause a horizontal compression. If B is very small, it's going to cause a horizontal stretch. So in other words, if B is 1/2, we're doing this to the original function. If B is 5, we're doing this to the original function. So we're going to say that this is a horizontal stretch or compression. And it's a stretch whenever the B value is greater than 1. And it's a compression whenever the B value is basically a fraction. So less than 1, greater than 0. So like 1/2, 1/3, something like that. So let's go ahead and graph based on how these numbers work out. First, let's get our sinusoidal axis value. That's going to be this last number here, which is 1. So we're going to say our sinusoidal axis is going to go through y equals 1. Not perfect, but that'll do. That will put us here at most, or here at the least. The phase shift is this part on the inside of our parentheses that we're adding or subtracting. And it's the opposite of what we would normally think. Addition moves it to the left, and subtraction is going to move it to the right. So what we're going to write down here is that we have a phase shift of pi over 6 to the right. Now let's find the period. Remember, first of all, this value here is what we call the B value. And also remember that the period is the same as 2 pi divided by that B value. So in this case, we're going to say that our period is 2 pi divided by 3, basically about 120 degrees. We might also work out something called the step. And basically that's saying, look, we don't want to get all the points, let's just get the major ones. And we know normally the major points go every 90 degrees. So basically what we're saying here is that if we change the period, the step is going to change too. And normally it's every 90 degrees, but because we're changing it by b, then our step is 90 divided by b. On this problem, that's going to be 90 degrees divided by 3, which means that every 30 degrees we're going to get one of those major points that we need to make our graph. So now let's put this together and actually put our points down to make the graph. To graph this, first remember that we have a phase shift of pi/6 to the right, which also means 30 degrees to the right. So remember that normally we would start at the center. So we would normally start on the sinusoidal axis. Remember, this is what the sine graph looks like. So we would normally start on the sinusoidal axis, and then we'll go 30 degrees over, and then we'd have another point, and 30 degrees over, another point, 30 degrees over, another point, and we would keep alternating like this every 30 degrees if we didn't have a phase shift. But we do, so that means that everything is going to move to the right by 30 degrees. So our initial point, as opposed to being where it was, is going to be 30 degrees off center. Every other point is going to be 30 degrees away from that because our step is 30 degrees. In other words, we're going to increment by 30 degrees every time we go to the maximum, to the sinusoidal axis, back to the minimum, up to the sinusoidal axis again, and so forth. So our next point is 30 degrees over. Then 30 degrees over from that, we have another point. 30 degrees over from that, we're going to reach our minimum. 30 degrees over from that, we're going to reach the sinusoidal axis again, and we'll continue repeating this pattern until we get the rest of the points. So back up to the maximum, 30 degrees over, sinusoidal axis, and let's go ahead and finish out the rest of this pattern. And let's connect everything. I know I didn't mark off the spacing and everything on the last graph, the degrees or radians, but I think on this graph, just to avoid confusion, I'll start off by doing that. I'll mark off the angles. So 30, 60, 90, that's 90 degrees or pi/2 radians, 30, 60, 90. This is pi radians or 180 degrees. 30, 60, 90, this is 270 or 3 pi/2 radians. And then we have 360 degrees at the end here, which is 2 pi. I'm going to go ahead and mark off the negative versions as well. Now let's graph the sinusoidal axis. We said that that one went through -1. So y equals -1 was our sinusoidal axis. Because our amplitude is 3, we know that the furthest up that we're going to go is 3 units up, which would put us here. And the furthest down that we're going to go is 3 units down, which would put us here. Remember that before we put down our first point, this is what a cosine graph looks like. So a cosine graph is going to start at a maximum value. So it has to start at a maximum value. But notice that we have a -3 here. So remember we said a few minutes ago that this negative is going to come into play? Well, this negative means that we are now going to reflect our graph. So we're going to reflect it across the x-axis. So what that means is that anything that was a maximum is now going to be a minimum, and anything that was a minimum is going to become a maximum. So because the cosine would normally start at a maximum value, instead we're going to say that it's going to start at a minimum value. We just said that we would normally start here. But the thing is that we have a phase shift of pi units to the left. And what that means is that we're going to actually move this initial point 180 degrees to the left. So if we did that, our initial point would end up here, 180 degrees or pi units to the left. So now let's work out our steps so we can see how much we have to go for every single point. So remember we said that the step is 90 divided by our b value. So that's 90 divided by our b value, which again we said was 1/2. As we said before, divided by 1/2 is the same as multiplying by 2. So this is basically 180 degrees to get to the next point. So that's our increment. So let's go ahead and graph the rest of the points. 180 degrees over, and we're back on the sinusoidal axis. 180 degrees over from that, and we're at the maximum. 180 degrees over from that, and we're back on the sinusoidal axis. Now let's reverse it to get more points on the other side. Actually, we just have one more point to get. That's our point. If we connect everything, this is what it looks like. So that's our graph. Notice that the 1/2 actually caused the graph to stretch, whereas if we have 2 or 3, it's going to compress the graph and make the curve a lot closer together. It's going to increase the frequency. So that's it. That's how we graph sinusoidal functions. I would love to have your support to help the channel keep going, so please remember to go ahead and hit that subscribe button, as well as give me a like on this video. Until next time, see you.